Greetings, everyone. I know many of you in the audience here. I've been coming to COFES for about 15 years. I think I've only missed 2 times. But by the way, how much time do I have for this presentation? Does anyone know?
About 40 minutes.
About 40 minutes. Okay. So my name is Marc Halpern. For those of you where we don't know each other, I'm a research vice president at Gartner. I've been involved in this area primarily with product design and engineering for about 30 years now. And I became an industry analyst for actually even longer than that. It's frightening. And I've been at Gartner for the last 14 years, leading up their product lifecycle management and engineering. Now, the content I'm going to share with you, and you know, a lot of you know I'd always been involved with finite element analysis, computer-aided design, etc. I'm presenting something totally new for me, which is more about supply chain. Brad called me up like a few weeks ago. He says, "Mark, can you present at this DaS conference?" So I said, okay, I'd give it a try. And then I was talking to Scott, and he said it was about sustainability. So I happened to be reading a book about sustainability and new economic models, and I'll talk a little bit about that. So there's going to be some of that in the presentation, and a lot is going to be more IT-ish and things you might have heard about PLM already, but it has a different angle to it. So, you know, if you have any questions, we could do this casually. And if you need to talk or you're getting bored, falling asleep, and you want to raise your hand and say something, feel free to. So I was going to talk about, it's a new IT trend, product innovation platforms. But there's a different spin to it. It has more to do with the challenges in the supply chain. And I've been doing a lot of reading about complexity lately. And the reason I've been doing a lot of reading about complexity and systems, and I know Jack Ring and we had a very good discussion a few weeks ago, is because the nature of software has changed everything. But I've become now very intrigued with the science of complexity. And what is a complex system? Well, a complex system, you know, just because, say if it's a mechanical part and you see lots of moving parts, it's not necessarily complex. It might be complicated. But if it's very clear that part A affects part B, affects part C, it's not necessarily complex because cause and effect is there and it could be represented by a directed graph. Certainly chaos or totally ergodic processes are not complex either because the possibility of any event happening is equal. But systems like this are complex. I look at the one fluid diffusing into another fluid, and a slight perturbation in terms of temperature or pressure can change the behavior of this system. So their underpinning it is there are rules of behavior, but they are so sensitive to environmental conditions that the behavior can indeed change and cause and effect can change. And that's, at least in my definition, what makes it complex. Supply chains are certainly complex. Here are some of the factors that influence supply chains. If we think about the tsunami and the meltdown of the nuclear power plant in Japan, clear supply chain disruptions. Those supply chain disruptions produce material and resource constraints. All of a sudden, manufacturing is affected. And perhaps they might, companies, they're going to look for alternative suppliers. It impacts cost, impacts whole bunches of things. In the global world, with very diverse market demands, with many different types of regulations, and then you design a product, and then all of a sudden, materials become scarce. And then all of a sudden costs go up. And then you try to find substitute materials that might not necessarily comply. But these types of behaviors, one thing that changes that affects the dynamics of other things, and even if sometimes those changes are subtle or small, is really what makes systems complex. So supply chains are indeed complex. So what I was going to talk about, and actually I shouldn't admit this, but this is my rehearsal for the supply chain conference that Gartner's putting on in May. So this was very convenient that Brad asked me to talk, and I hope you don't mind.
Full disclosure.
Full disclosure. Okay. Was number one, why do we need what are these product innovation platforms? So in the first section, I'll give you a sense of some of the characteristics of what I'm talking about with these product innovation platforms. And in the second section, I'm going to give more of a definition of it. It's actually the world of PLM is evolving to this. And we're not saying necessarily that PLM is going away. PLM was there, product lifecycle management, from before even that the digital computer came on the scene. We'd been doing it for centuries. Well, successful companies, since we've had commercial companies, have been managing their product life cycles. But the technology is indeed changing, and there's clear benefits to the supply chain. And then I was going to provide at least some recommendations to supply chain professionals. We'll see if we get there. Okay, so why do we need these? So this is your typical supply chain. Your typical life cycle, starting with new opportunities for products, innovating, developing, commercializing, etc. I'm sure you're all familiar with this. And then here are some of the questions that are typically asked. And the supply chain needs to be involved. They have to be involved in the discussions of whether or not the product concept is feasible. And I know a number of you I see in the audience are tier 1 suppliers, correct? And the OEMs need to be engaging you. Can you do this? Are the requirements indeed achievable? Some of the greatest risks to products and the greatest failures have been miscommunication of requirements. I would say, those of you in the aerospace industry, isn't it fair to say that requirements management or miscommunication of them was a significant bottleneck with the Dreamliner?
Absolutely.
Yeah. And it's true with lots of other products as well, and software is complicating the situation. Some of our clients are household names in consumer electronics. And where are the requirements breaking down? If not in hardware, certainly in software that's becoming part of products, where in industries like automotive, consumer electronics, and some others, 70% of the software is coming from the supply chain. Concerns about cost and quality targets, that's always a big issue. Then when it comes to production, if you think of, what was it, PlayStation, I think it was a PlayStation or 1 year, trying to think, I can't remember now. This is what happens as you get a little older. But let's put it this way. If there's a hot product you have and it's not available, there's windows of opportunity that are lost. When it comes to service, particularly for products with long life cycles, this becomes a big issue. And then when you want to retire the products, an interesting thing is scale down of products can be almost as challenging as new product introductions, in that you want as little dead inventory as possible. The challenges that occur in the supply chain, actually this is the old presentation, but that's okay, are not enough. Okay, number one is suppliers are typically not involved early enough during product definition, design, development, at least by an OEM. And this is all based on a survey that Gartner had conducted with about 350 companies or so. Feedback also that suppliers were not represented sufficiently during design reviews. Sales and operations planning and new product introduction were not aligned to each other. So they might be introducing a new product, but the retailers have to be engaged, the suppliers have to be engaged, etc., and there's not enough of that going on. Again, thinking about the supply chain systemically. And another issue, again related to systems, is that very often an OEM will design a product not necessarily thinking about an overall product platform. So they introduce product by product piecemeal, which creates additional unneeded complexity and waste. How many of you are suppliers in the room? Would you agree with the results of this pretty much?
Generally.
Generally? Okay.
Not in every case, but generally.
Okay. Only 50% of new and modified product launches, according to the survey, are considered to be successful in terms of time, budget, and achieving volume and profitability targets. All results of the survey. Now, this is supposedly about sustainability as well. So I was at a conference in Europe last October where some people presented from the University of Delft in Netherlands and came up with a concept of linear economies versus circular economies. This is a linear economy. The idea that you have suppliers providing parts and materials to a product manufacturer who then sells either directly or to retail service provider. It could be consumable goods such as food and beverage, chemicals, whatever, or what user represents is discrete products that are not necessarily consumed. And what we want to do is minimize energy waste, landfill, pollution, etc. It's very difficult to do with what's called a linear economy, and this is a new trend. I'm seeing more of it in Europe than I necessarily see in the United States. Things like initiatives from the European Union such as REACH, which is to minimize throughout an ecosystem the amount of chemical waste or whatever, as well as ELV from the European automotive industry, end of life of vehicle, that in excess of, I don't remember the exact percentage, but north of 95% of the vehicle needs to be recyclable. So what is being proposed is what's called a circular economy. A circular economy, if we think about consumable products, and actually, Jack, your comment before was very interesting related to agriculture, that we become productive in agriculture, but we're undermining water resources, soil, etc. But the idea is to think of the chemical processes to restore raw materials, either take waste or byproducts of manufacturing and chemically treat them in ways that, if they're indeed biodegradable, producing methane or other useful byproducts, or even other chemicals, and creating ecosystems of waste so that you could perhaps even replenish soil for regeneration of the raw materials that again would go into products. In the discrete side, and so that's called circular or a circular economy. On the discrete side, there's different levels. If you think about the user or end customer, providing them as much support as possible for maintaining products, the retail or service provider being able to reuse parts, the original product manufacturer to remanufacture or refurbish products, and being able to recycle as many parts as possible, even going back to the supplier. So what does this mean? This means that throughout the entire value chain, going from the customer to the retailer to service companies to the product manufacturer to the suppliers, we need even greater collaboration capability, think even more systemically about the whole product life cycle in order to accomplish this. And the need for doing this is becoming more and more severe, given the rapid rate at which we're consuming resources, water pollution, air pollution, etc. So we talk about product innovation platforms. And these are what we say are the main benefits of such platforms. The platforms provide community across the value chain, probably most importantly, accessibility of members of that supply chain, adaptability to change processes, to change roles, to change players, ability to search more effectively than ever for content. And the search tools are getting better and better with semantic web and graphical search. For example, these search tools based on geometry. Using more and more analytics in platforms to gain insights. So, for example, looking quicker than ever for defective parts, or customer feedback, or any type of analytics. And then finally, discovery, as more and more simulation tools are infused into the software ecosystem, as well as even from analytics, the ability to juxtapose more effectively than ever and get graphical views of the patterns and trends and data to help us with both insight and discovery. So some of the basic impacts of this is, I would say, today we really do not have the analytics built into the tools to the level that they should be. And we see a lot of improvements happening in that domain, whether it is an SAP with business objects, Oracle, DaS07 systems. I haven't seen as much from Siemens and PTC, but they certainly talk about it. Adaptability, a lot with service-oriented architectures. So, for example, with tools like Aris, one of my clients that I was talking to recently, Aris has a service-oriented workflow, had said to me that there were currently, well, I'll just say, another big vendor that when they have to switch suppliers very quickly, changing workflow is a 2-week IT project. Whereas it could be done, the Aris demonstrated that they could do it in 20 minutes or less. Reuse, I already mentioned that the tools are just getting better and better, using visual search and even semantic web. There's a company called Conweaver out there now that's used techniques of semantic web. When I talk to my clients, they bring together data from Teamcenter and SAP, and searches that would take them hours, they say take a matter of minutes now. Accessibility with the cloud and mobile has gotten a lot better. Discovery and community. Discovery can be much more systematic. The simulation tools are getting better. And more and more of my clients are asking for social networking type software, which is really interesting, not just for looking for talent and expertise outside their companies, but even within their companies, to find if people have the skill sets to help with the immediate needs. So all of these are going to lead to, or they are leading to, more ability to engage value chains. So why is this all happening now? Well, there are certainly certain business drivers why these innovation platforms are evolving now to support the types of issues I shared in the last section. Number one is expectations of products are shifting. Products are very software enabled now. Well, we all know that. Global markets, and I get a lot of requests on this, not just from discrete manufacturers, but process manufacturers. I do have the privilege of traveling all over the world. It could be Kellogg's Corn Flakes. I get them in Japan. It might have a little Japanese kid on it. You go to Northern Europe, it's a little blonde-haired girl. Obviously differences in language, different regulations, but how do you manage all of this? How do you ensure not just that the product conforms to regulations, but even the packaging conforms to regulations? Certain things are permitted and other things are not permitted, even related to packaging. Internet of Things and digital business, there's a lot of hype about it. But we still have to design those things to work. And it's really amazing, and I'm going to criticize my company a little bit, because everybody talks about Internet of Things, and as if this is some magic or panacea or something like that. This stuff has to be designed, and it is pretty darn hard to design. And we have to look for new tools, and I'll share with you a very high-level architecture of those tools. New business models. I already mentioned there's two trends. Number one, the circular economy that I spoke about, but the other is products as services, which also dovetails with this idea of circular economy. You don't buy a car. Well, we've had leasing for years, but now the concept of zip cars, or you lease jets, aircraft. I mean, even right down to bicycles. Whether you go to Paris or Palo Alto, you can now rent bikes. And you put your credit card in, you pick the bike up one place, drop it off somewhere else, put the credit card, it tracks it, it bills you. So products as services. Even Netflix, you think about it, it's really product as a service. And shifting product development priorities. This world is changing. Last year, I was at in Northern Europe, a telecommunications equipment manufacturer. They said today, for every mechanical engineer, they have 6 electrical/electronics engineers. And for every one of those engineers, they have 10 software developers. Ratio of 60 to 1. It's quite a different mix, which means we need different tools. Okay, one of the biggest problems related to infrastructure is orchestrating software development, which has such a different dynamic than hardware development. Okay, the changing IT landscape, the platform shift primarily going to the cloud. It's certainly public. I mean, even look at what John Hirschtick did. Founder of SolidWorks is now hot on to Onshape. He presented here. It's in the cloud. And by the way, I played with it some. It's great. I mean, I was on my PC, developed some simple parts. I get onto my iPad. I was at an airport. Bang, I bring it up, change the part, go back to my PC later on. It's all there. It's incredibly fluid. The new business models, everything is now going to subscription business models. And, you know, the vendor justification for that, of course, is saying, okay, updates won't be as difficult. You don't need as big an internal IT infrastructure. But let's face it, they're making more money too. Licensing for paid-up licenses was typically 18 to 22%. With these with these subscription models, using the paid-up license fee as a basis, it's now 30%. So it gives them a nice bump in revenue. New functional requirements. I already suggested that systems engineering, system simulation, system-centric thinking, portfolio management, which supports that, new tools for developing product architectures, etc. So the IT landscape is changing as well. Now, with all of this, as I said before, the IT may be changing, but PLM remains the same. PLM, at least in our definition of it, it's governance at its very heart. We use it, our layers of PLM are to strategize products, plan how we're going to deliver and support them, actually content capture and control and execute, creating product portfolios throughout the life cycle, and supporting from the demand, the full value chain from market demand through suppliers. None of that changes. And we will continue to cover PLM, but it's about engaging the value chain with a new platform that makes collaboration easier. At the basis of this platform, there's cloud, there's mobile, there's social, and analytics. basically retrieval of analytics. That was more of the insight and discovery piece of this. Taking a look at those dimensions, here are the tools. Now, does it all have to be integrated? No. Everyone talks about integration, but integration adds complexity. Some things need to be integrated, but I prefer to talk about orchestration of tools. In terms of a logical architecture, the basis of it is still product lifecycle management, but connected to that, we need portfolio planning and management. Why? To design those product platforms so you can produce families of products for the market in a holistic rather than a piecemeal way. Requirements management is absolutely critical. Requirements coming from customer data, cost data, whether it's from the factory or from the supply chain, whatever, consuming new hot ideas, what you're hearing about the existing products in the market, and system-centric design, and getting those systems right. And by the way, systems is not necessarily software, electronics, and hardware. In the formulated product world, it has to do with labeling, packaging, the chemistry, etc. Building those variants that address the preferences of different markets, if it's food and beverage, whether it's taste, color, whatever. Yet, there is that brand recognition. So, for example, you take something like a Nabisco cookie. We've all had an Oreo. They're very popular here, but the Oreos we like here are not so popular in China. They prefer a more wafery crust and the filling not as sweet. But you still want it recognizable as a Nabisco product. So how do you produce that variety? And then finally, simulation and test. And I'll be talking in the assess program about how simulation and test data is a way to generate more knowledge and deeper understanding of requirements. So when we talk about the product innovation platforms, besides having that infrastructure for communication, etc., this is all involved, and when I talked about circular economy, etc., this all supports it. Now, is it really happening? And this, we call these strategic planning assumptions at Gartner. By the way, how much time do I have?
About 10 more minutes.
Oh, okay. By 2020, 25% of large discrete manufacturers and process manufacturers for formulated products will use such platforms for design and PLM. Why? Because, number one, digital business is going to mandate it. Number two, looking at the platform of the cloud, it'll be accepted. And number three, the changing product requirements. And actually, number four is the vendors are already doing it. I was just at the SAP Insiders event. They were talking about innovation platforms. When I went to the Oracle Value Chain event, they were also talking about it. Dassault Systems, when they talk about their 3D experience platform, that's what it's about. Siemens is talking more and more about Teamcenter as its next generation platform. PTC is using the language more related to its Windchill infrastructure. This is happening. But there are some challenges associated with this too. I talk to a lot of my clients and they ask about, well, if it's in the cloud, how do I support my intellectual property? My belief is your intellectual property is actually safer in the cloud. Why? Because number one, most intellectual property is stolen by people. It's not hacked. And you can never quite get contextually rich enough information by hacking systems. Number two is most users hate using PDM systems. Let's face it, okay? So what do? Do they check in and check out with the PDM systems? No. They simply attach their content, their files, to an email. And then that email could be sent somewhere else. And so the content actually propagates, whereas in a cloud-based repository, it's in one spot. And that was another thing I experienced playing with Onshape. Number two, the systems-based learning curve is too steep. At the end of February, I visited a major European car company who's trying to go through this journey of system-centric design. And what they shared with me was that while their PLM evangelist really wants all of this to happen, manufacturing doesn't want to hear about it, because part of the implication, they have to treat bills of material differently. And engineering wants nothing to do with it, and manufacturing wants nothing to do with it. So how do you manage that cultural change? And also, for such broad collaboration to happen, we need the standards. I heard a comment mentioned in the last presentation related to standards comparing the construction industry to the agricultural industry. Well, us people in this type of manufacturing, it isn't that much different. And I don't think the vendors help all that much. So, who's getting involved with this? Well, certainly companies like Autodesk, Dassault Systems, PTC, Celerant, and Siemens. And by the way, of these, I'm getting more requests from my client base. And we have over 10,000 clients, of which more than 3,000 are manufacturers, about Eris. Eris seems to be on fire right now. The companies like SAP, Oracle, even Infor, with their Infor 10 platform. They're talking more and more about platforms. And in recent years, they have a renewed interest in PLM. There's also specialty companies. Big Lever, I just did an analysis of them. I'm very impressed with them in terms of systems engineering and managing requirements in a very system-centric sense. Gensight is also more on the product portfolio management side, building product architectures, etc. I'm impressed with them as well. JAMA Software, requirements management. They had been deep into the software industry, and they're seeing this opportunity for managing mechanical requirements as electronics requirements. And I think the software industry is having a huge impact on requirements management overall. Planisware and Sophion. Now, what is not on here, which is on the other version, is Amazon, Microsoft, Google, and IBM. Why not? I hear them talking more and more about this as well. And boy, if they get into the fray, even if they're not providing the tools like a Dassault Systems or a Siemens or a PTC, they have enough of this infrastructure they can make it awfully interesting. Okay, I'm actually, since I don't have too much time left, I'm going to bypass the case studies, but this is just the idea of digital content. One of our customers in the fashion industry, basically taking ideas bringing those ideas, sending them to a remote location, brainstorming, but engaging their suppliers in Asia, as well as suppliers and retailers in North America from very early on in the product development. If you remember when I talked in the very beginning about sales and operations planning and new product introduction and getting that input very, very early on, that these suppliers and even the retailers contributed a great deal right during the brainstorming about this product, and it was basically creating a knockoff of a very high-end fashion product for a broader community. Took them about 6 weeks to get it out to market, which is pretty impressive. Now, this is another case of a company, actually a European food and beverage type company that has this goal of getting all artificial ingredients out of its products within the next 2 years. And, just depicting here that, hey, they serve all of these different markets, and they have to deal with farmers and very, very complex supply chain for a very broad number of products, as well as the labeling and artwork, as I described, to match these different markets. And they're also thinking in terms of circular economy. But it's a whole value chain engagement here. So I think what I'm going to do is I'm going to leave off here. On my presentation, I'm just going to talk about the perceived risks, and I don't know if I'll have time if anyone has any questions. But what are some of the perceived risks we see? Number one is inadequate openness. Collaboration requires a common semantics and understanding of content. And it's not there yet. And these standards seem to move glacially slow. Number two, incomplete standards. Number three, uncertain cloud performance. The cloud is not equal everywhere. Sometimes, I know even at Gartner, some of our apps work on the cloud, and performance is inconsistent. As I mentioned, with the example of that European auto company, the learning curves are steep. And actually concern about cyber attacks. That if we're depending so much on more of a centralized compute capability, this becomes more and more of a risk. In fact, I was at a meeting in Italy about almost exactly a year ago from today, where I ran into some clients of Gartner from it wasn't the CIA, it was another one of these securities agencies. But I was amazed at how many potential attacks are fended off on cloud-based security. They're not going to be successful all the time. So I think I'm going to stop there. Basically, when I talk about implementation, it makes sense. Where are you today? Evaluate your business case to justify making the investment in these platforms. But you can't do everything at once. You do a root cause analysis to stage the implementation, select your partners, navigate change. And just talking about the, I talk about the metrics of a maturity model, or how to measure where you are in order to assess where you get started. So anyhow, any questions, comments? Yeah?
The only thing I want to add, I was really struck by your circular versus discrete economy concept.
Oh, circular versus linear.
Well, okay, linear.
Yeah.
Well, then you went on to talk about circular versus discrete, and then I got it. And just as a FYI, are you familiar with the Cradle to Cradle initiative, William McDonough's work? He's an architect working with a chemist.
Actually, when I was doing research on that, I ran across it.
So he created this concept, or well, I won't say he created it, but he's very much developing the concept of a circular economy, and he's identified 3 parts. You had 2 of them. You know, the end of life of vehicles, you know, is an example. But he calls it the technical nutrient flow, which is products and materials that can go right back into industrial processes, versus the biological nutrient flow. And you had the biological nutrient flow up there, but you called it discrete, and that was what he talks about, the technical nutrient flow. So he thinks of these things as nutrients, technical nutrients, biological nutrients, but then he's got a third category that a lot of people don't want to talk about. He calls it the monstrous hybrids. And he believes that manufacturers themselves have to take responsibility for the monstrous hybrids, to store them until we develop the technological capability to either turn it into a technical nutrient or into a biological nutrient. The monstrous hybrids are those materials which we cannot return to the ecosystem, which we cannot get back into industry, and they're dangerous. Somebody has to take responsibility for storing them until you can get rid of them. Radioactive waste being one of the best examples of a monstrous hybrid.
Yes.
So cradle to cradle is pretty interesting stuff if you're interested in a circular economy.
Yeah. Okay, any other comments, questions? All right. Thank you very much.